So hi, this is my lab 1 and my name is Samantha Forero-Rodriguez. So the introduction. So for lab 1, the purpose was to analyze the motion of an object in motion after recording a video of it moving in constant velocity. We will then compare our recorded experimental data to our predicted data in the computer model, which in this case was Tracker, and we recorded and analyzed the object's motion using a straight line. And then we're going to build a computational model based on Newton's second law, which is F is equal to mass times acceleration, and then we're going to do the comparison between both. So a couple of fundamental principles. As I mentioned, formula F is equal to ma, that describes how force affects an object's motion. Net force equals to 0, that means that it's in constant velocity. When net force is not equal to 0, that means it's accelerating or decelerating in the direction of the net force. Newton's first law says an object at rest stays at rest, and then Newton's second law says acceleration of an object depends on the force applied to it and its mass. And Newton's second law is also going to be important here, so we're going to be using the velocity update formula and the position update formula. So moving on to the actual experiment. So here is the tracker. So my graph is a little wonky because I did it vertically rather than horizontally, but as you can see, I put each little point according to the center of mass of the system, which is the center of the marker, and that way I was able to graph how it was moving. So predicted motion. So again, it's opposite, but this is how it would be if there were no external factors such as drag, or if the marker were to move in a perfectly straight line. So, and then on the right, that's the code that I did. So I did have to calculate the net force. I changed the time step, which in the tracker I had to be every 0.01 second. And then here is where I used Newton's second law, where I updated the position and the velocity according to this formula. And then here you can see the observed versus prediction. The one on the left is just the observed versus the one on the right is both, where the green is the straight line perfectly, and then you can see that the blue line is a little wonky, and that's because of other factors that cause the marker to not be in a perfectly straight line. And then possible sources of error. So there could be a tracking error that's inconsistent tracking of the object's motion, position frame by frame in tracker due to motion blur or manual error. So that could be the actual video not being held correctly the whole time, or me not putting the point when tracking it in the exact center of mass each time. Frame rate limitations, so low frame rate could miss small changes in motion affecting accuracy. This could be due to my phone not being of best quality. And then camera angle misalignment, so a tilted or non-perpendicular camera can distort the observed motion. So the camera was held from an angle from above, and I did not use a tripod or a stand or anything, so it was just a fellow lab member holding it, and the chances of them holding it perfectly still for the entire duration of the video is unlikely. And then friction air resistance, so neglecting Sol's forces that lead to slight deviation from the expected constant velocity. So this is just, since a marker is going to be in motion in a real system that's not perfect, there is going to be other factors, or energy loss to the surroundings such as sound, since the marker makes a sound as it moves across the table, or drag, and that happens as it increases velocity. So the conclusion, so constant velocity, net force. Constant velocity means that balanced forces, net force equals to 0, and push and pull forces cancel out, and that means that there's no acceleration. So my what if question is, what if air resistance was considered? Then air resistance acts opposite to the motion, creating a net force, and the object would slow down. So this would go against the idea that there's constant velocity as there's deceleration. And then predicted data would be shown decreasing over time rather than a straight line. And then larger objects or higher speeds feel more air resistance. And that's it for my lab.